machine learning capstone project. This project is individual. Project summary. I have been provided with the historical sales data of the Rossmann stores, which has the 1,115 sales data. My task is to forecast the sales for the upcoming 6 weeks in advance, and it has been mentioned that some of the stores were temporarily closed for reimbursement during the period of the sales was zero. I have two datasets. Firstly, imported from the both dataset. One dataset is Rossmann stores, which contains 10 lakhs above of rows and 9 columns. The dataset doesn't contain any null value or duplicate values itself. The other dataset is store, which has 1115 rows with 10 columns. This dataset contains many null values in different columns. It provides information like types of store, what are the store assignment on the level used in the store, for how far the competitor from the store, since how long the competitor is there in market, and how often the promos is applied on the stores as well. I drop some of the columns from the dataset, store dataset, which contains too many null values, in field with some features which contain very less amount of null values. Then I merged both of the datasets and I checked for the outliers. There were some columns which contains outlier and then treated them using the percentile method. Then I performed the EDA, univariate, bivariate, and multivariate analysis also to extract some useful insights from the data. Then I performed the feature engineering and data pre-processing, in which we perform label encoding and categorical features and define some new features also in there. Then we will calculated the VIF to find the multi-collinearity between the features and the selected important features for the further analysis. Then we split the data into dependent and independent variables and transform the data using the standard scaler. Then I split the data in X train, Y train, X test, Y test with the test size is 0.2. At the end, I implemented the model on my data like linear regression, ridge regressions, lasso, elastic net, decision tree, random forest, and XGBoost model on my data. Based on the performance of our model, I have selected the XGBoost as my final prediction. We will see about that why I have choose that. So let's begin this. There is a GitHub link for that. Problem statement. Rossmann, it is a retail chain operator, extensive network with over 3,000 drugstores across 7 European countries. Currently, they are facing the challenges that Rossmann store manager resolves around predicting daily sales for up to 6 weeks in advance. Numerous factors such as promotion, competition, school and state holidays, seasonality, and locality to contribute the dynamics of the store sales. This complexity arises from the diversity of circumstances faced by individual managers, leading to the varied accuracy in their sales prediction. The primary objective is to forecast the sales column from the test set, bearing in mind that certain stores in the dataset were completely temporarily closed for their refurbishment. Here are the general guidelines. Let's begin the new data. We have import the libraries. Then for the dataset loading, we have mounted our drive. Then we will load the both the datasets, raw store and the store. Let's see the first view of the dataset. First, Rossmann store, then the store, dataset rows and columns. We'll print the shape of the dataset, number of rows in the dataset, and number of columns in the dataset in the Rossmann store. So the number of rows in the dataset is 10 lakh 17,209 and the columns are 9. Then we'll see the stored data set also again with the same method. So we have 1115 rows and 10 columns also. Data set information, Rossman store info. We have no null values in this data set. The date and state holidays column have date types objective, data types of objective. Store data set. This data set contains numerous missing values, that means null values. The columns store type and assignment are of object data type. Let's see the duplicates value. So the Rossman store doesn't contain any duplicate values. The store duplicate any is full. Store dataset doesn't contain any duplicate values as well. Missing null values. So the Rossman store doesn't have any null values, but the store dataset have the null values. We'll print the percentage of the null values are also in the row store dataset. That is, there are too many columns which contain null values. Some of the columns have nearly 50% null values. That is a very high percentage. So the percentile descriptions of the column. So there are some columns which contain outliers like sales and customers. We'll describe the store dataset. Competition distance column contain outliers. So promo to since week, promo to since year, promo interval, competition open since month, and competition open since year contains too many null values. So we'll install pick missing number. We'll then import the as a MSNO missing number. Then we will figure it. So we can see that there are so many missing value null values are over there. In the competition distance, competition open since month, since year, promo since 2 week, promo to since year, promo interval, etc. So we are working on the dataset related to the Rossmann company, which comprises two dataset, that is Rossmann store and another is store dataset, in which Rossmann store has no null values with the rows are 10 lakhs, 17,209 rows and 9 columns, which is remarkably the dataset devoid of any null values and duplicates. And this, on the other hand, store dataset which has so many null values in a different columns. So the information provided include detail about the store type, the assortment level utilized in the store, understanding your variables, Rossmann store columns and the store columns. Variables descriptions is here. Then checking for the unique values for each variable. We will apply the lambda function and then we will get the unique value counts. So state holiday contains O instead of 0. Then again the checking the unique values in the store data set. Then we will print about that. Then we'll do the data warning. We will need to drop the some columns from the store data set, that is promo interval, promo to since year, promo to since week, competition open since year, and the competition open since month, because they have so many null values in there. So we'll drop it. Then we will fill the null values in the competition distance column with the median. Then merging both the data set on the store column using the merge method. Then we'll have the look for that data after the merging. So the data shape is 10,17,209 and 13 columns now. We need to convert the date also if it is a string column. If not, conversion may not be necessary also. Then we'll create year, month, and week number columns also. Then we'll drop the date column from the frame, data frame. Now we'll do the outlier treatment. Import the C1 and matplotlib yplot. So the competition distance and sales have so many outliers, and the customers too. But the competition contains maximum. We'll find out the 90, 95, 95, 99 percentile values of the competition distance column. From this we can see the 99% value is around 36K and maximum values is around 75K. So let's consider only the 95%. Then we'll find out the 90, 95, 99 percentile in sales column again. So in sales feature also outliers is there, and let's consider only the value for around 95%. Then we'll do the same with the customers data. So let's consider the value around 1400, that is around 95%. Then we'll create the copy of our dataset. Sheet before the outlier is 15 columns and 10,17,209 rows. Let's treating the outliers, calculate 95 percentile value, and filtering the dataset with Boolean indexing. After treating the outlier treatment, we have the shape is 90,000, 9 lakh 8,510 rows and 15 columns. We'll create the state holiday column with the binary values 1 for yes and 0 for no. Then we'll drop the column state holiday access1 in place true from the dataset column. What all manipulations we have done? Initially, I eliminated the column containing the excessive null values like promo interval, promo to sincere, promo to since fake, competition open sincere, competition open since month from the dataset, store dataset. I address null values in the competition distance column of the store dataset by filling them with the median value. Next step is involved the merging of both the dataset. Then we generated the new columns year, month, week, num from the date column. The date column was dropped again. Then identification of the outlier was carried out through the box plot, competition distance sales in. Now the data visualization storytelling. Sales versus day of week. It was mentioned that some of the shops were closed due to some reimbursement. So sales during that period was zero. So we'll create a data frame that filter out those days. We'll create data sets where sales is not equal to 0. Then we'll plot the graph, sales versus day of week. We have used the bar plot to see the sales over the weekdays. It has been found that the Monday has got maximum sales and day 7, that is Sunday, has got the least. For the bar plot, it can be seen that after day 1, there has been decline in the sales. Sufficient measure should be taken. Second chart is sales versus promo. We do the bivariate analysis, then again the plot, the graph. We have used the bar plot to see the relationship between the sales and the promo. It has been found that the sales get almost double when the promo is running. So the business should try to run more promo in order to get the most sales, and particularly when on those days where the sales are the minimum. Chart 3, sales in different months. We have seen the sales of the month trend. We have to pick the line plot for that. Then we have seen that after the October there has a very large growth in the sales that might be due to the festival season. December shows the maximum sales maybe because of the Christmas and the New Year. So from the plot we can see that sales has been dropped in the month of May. So the management need to focus on this. They can also run any promo or increase the sales. For this, sales in different stores over different years. We have to pick the bar plot for find out the sales over the year in different store types. It was found that the store B sales has increased from 2013 to 2015. In 2013, store D has maximum sales, and remaining years store B has the maximum sales. So B has the increased all over the year, but the sales in the other stores remain almost the same. So other stores should try to use some business tactics as the store B is uses. Sales versus school holiday. From the graph, it can be seen that the very good sales when the school holiday is there, and also the good sales can be seen there when there is no school holiday. Chart 6, sales versus state holiday. It has the similar one, but not the difference too much. We have picked the bar plot and the pie chart to find out the effect on the type of state holiday on sales. The state holiday doesn't affect the sales. Sales versus assortment level. From the plot, it can be shown that the store B only A and B assortment has been used, out of which assortment A got maximum sales. And also remaining store only A and C assortment levels has been, and they got the equal sales also. Sales versus customer. We have seen the scatter plot. It was found out that the customer and sales are positively correlated to each other. Sales versus competition distance. Most of the stores are very densely located to each other and have more sales. Since there is very high competition, in order to keep growing to the store owner need to run the attractive offers to attract the more customers to increase their sales also. Sales versus promo tool can be seen from the graph that running promo continuously has not been much effective towards increasing the sale. They should run the promo simultaneously or the weak alternative weeks. Correlation heat map is a it is evident that the promo open and customer exhibit a positive correlation with sales. It implies that the store runs a promotion, there is an increase in customer visit or leading to the higher sales. Multi-collinearity is present among the promo customer and the open columns. Then we will see the pair plot. From the graph, it can be seen then what all are the features that are positively correlated with the sales. Next is hypothesis testing. Based on our chart experiment, there are three types of hypothetical statements from the dataset. In next three questions, perform the hypothesis to obtain final conclusion. Statement 1. State your research hypothesis and null hypothesis and alternative hypothesis. Will perform the appropriate statistical test and we found that the p-value is 0.0. So they rejected the null hypothesis. There is significantly a relationship between the sales and the customer. In order to find that the relationship between two variables, I have used the Pearson correlation coefficient to test the hypothesis. The Pearson correlation coefficient measures the strength and the direction of the linear relationship between the two variables. Statement hypothesis hypothetical statement 2 will perform the again the appropriate statistical analysis test over there with the correlation p-value and Pearson. Again p-value is 0 and Pearson correlation coefficient is 0.4809. So it also rejects the null hypothesis. There is significant relationship between also the sales and promo. Hypothetical statement 3. Again, so the Pearson coefficient is 0.087. Again, it rejects the null hypothesis. So there is significant relation between school holiday and sales also again. Let's do the feature engineering in data pre-processing. We'll handle the missing values. We'll first check the missing value, then change the we'll convert the computation distance to integer using the round and as type. Then we will handle the missing value and missing value imputation. The data frame is already clean, all the missing values has already filtered during the AD process. We'll handling the outliers again. Outliers can lead to be the bias inside and the conclusion when analysis do the so we have to treat the outlier before the passing the data into our model. Categorical encoding, store type assortment column contains categorical values, so we have to encode them. So we encode both the columns, store type and assortment. In our store data frame, store type and assortment are categorical features. So in order to encode these features, I have used to get dummies function from the pandas for one hot encoding, as it is straightforward and easy to use function provided by the pandas to perform one hot encoding in just one line of the code. Feature manipulation and selection will install impute and fancy impute. X is equal to data. We'll again import the variance inflation factor VIF, then convert the data to the float. Then we'll using iterative imputer for imputation. Then calculate the VIF for each column. So the many feature has been the significant and multi-collinearity. So the year feature use also demonstrate high VIF promoting its removal. Both customer and open feature exhibit high VIF with correlation of 0.77 between them. Feature selection to selecting only those features which are important. So we have selected all which are important and create a new data frame. With all the feature selection, we have used the heat map to find out the correlation for all the features. So the day of week, customer promos, whole holiday, competition distance, promo 2 month, all these are the deemed significant. Each of these features possesses a variance inflation factor below 5, indicating low multicollinearity and demonstrate a meaningful correlation with the sales. Moreover, each individual features play a crucial role in predicting the sales. Data transformation. Let's create a data frame where sales is not equal to 0. We know that there are some values where sales is 0 because shop was closed due to refurbishment. Let's find out the keyness. Then we will do the data scaling again. Then we will splitting the data. We'll splitting the data in the train and test set. As the data is huge, I have chosen the 80-20 ratio by allocating 80% of the data in the training set and will get the enough data to train the model and captures the pattern and relationship in the data. Machine learning model implementation. First is linear regression. We'll find the coefficient and intercept. Explain the ML model and its performance using the evaluation matrix score chart. So we have the train set matrix and test set matrix also over there. We'll do the residual test and residual plot. The linear regression model has demonstrated that the R square is 81.2%. Its ability to explain the sustainable portion of the variance in the target variable, and the mean square error and the root mean square values both are on the training and test sample. It's low. However, recognizing the R square score is not exceptionally high, the next step is involving the implementing the cross validation and hyperparameter tuning. So cross validation and hyperparameter tuning is ridge regressions. So the best parameter is 0.1, best score is 0.81. Calculation matrices over there. So the ridge regression has shown the same performance as the linear regression. Next is lasso regression. For the lasso, we have the best parameters is alpha and 0.01, and the best score is 0.81. Then we'll do the calculation matrix. Lasso has they also shown the same results. There is no improvement in performance. So we'll do the elastic net. Again, the elastic net has the best parameter is alpha and 0.1. The best score is 0.80. So the elastic net has also shown the same result. I have used the grid search CV technique for the hyperparameter tuning. It systematically search through predefined set of hyperparameters and evaluate the model performance for each combination using cross validation. So the next model is the decision tree. We have also used the grid search with the decision tree regressor model. For the best parameter for the decision tree is maximum depth is 20 and the best score is 0.92. Calculation matrix. And then we will plot the residual plot for the decision tree. So the maximum depth of 20 exhibit excellent performance on both training and test data. Achieving a notable R2 square is 97.67% in the training on the training data and 93.18% on test data. Additionally, the model demonstrates relatively low mean square error and root mean square error is 13.68 and 3.68. So the cross validation and hyperparameter tuning for this. After performing the hyperparameter tuning in grid search using the grid search CV and cross validation, the decision tree model was further optimized. It was found that the best combination for hyperparameter maximum depth 20 and minimum sample leaf of 5 and minimum sample split was found to be 3. Next model is random forest. Following the decision tree analysis, we have now implemented the random forest with the 100 estimator and the maximum depth is 20, where the R2 score of 90% in the training sample and the 95.6% on the test sample, which means the model display low MSE and RMSE values on the test sample, specifically 8.7 and 2.96 respectively. Cross validation hyperparameter tuning for that. After applying a random search CV and hyperparameter tuning, it was found that the parameter n estimator is 100 and maximum depth is 20. The model gave out the almost the same MSC and RMSC and R2 score. Now the final, now the next is XG boost. We plot the residual plot. After applying XG boost with 100 estimator, learning rate is 0.1 and maximum depth is 30. Has shown the MSC train point 6.05 and the RMSC score is 2.46, which is the square root of MSC. This score represents the model performance and training data. Similarly, the MSC test score is 7.8 and the RMSC test score is 2.8. The model has shown the R2 score 96.97 on training data and 96.07 on test data. Approximately the 96% of the variability in target variable. The scatter plot also shown the residual mean of 0 and residual value is minus 0.09. So the cross validation and hyperparameter tuning for that. And the grid search. After evaluating the performance of all the model, we have chosen the XGBoost model and the ultimate prediction model. Specifically, the feature of learning rate is 0.1 and maximum depth is 15 and 100 estimator. Surpass other model in various key aspects. XGBoost model achieved impressive R2 score approximately 90% on training data and commendable R2 score around 97% on test data. With the MSCs of 4.7 RMSCs of 2.7. XGBoost demonstrates smaller prediction errors, signifying enhanced accuracy in predicting the larger variable. The model can be explained and presented through two perspectives, global and local. This provides the overenhancing understanding of the model behavior, and then this delves into individual instance and feature in detail. Conclusion: EDA extracting valuable insight from the data. Some of the noteworthy observations: Monday day 1 exhibit highest sale, while Sunday day 7 record the lowest. The implementation of any data or any type of promotion approximately doubles the sales during the period of October to the December, likely due to the Christmas and New Year festives. So we experienced sales increase from 2013 to 2015. In 2013, Stody recorded the maximum sale, but in subsequent year, BE Stody consistently leads in sale. Only 3% of sales are affected by the state holiday, indicating that overall sales are not heavily dependent on the state holiday. Conclusion for machine learning: we have applied several models, including linear wedge, lasso, decision tree, random forest, and XGBoost on the dataset. Assuming the performance, we have opted the XGBoost model as the ultimate prediction model. This choice is based on the XGBoost model's superior performance and the various key specs. Is XGBoost configured with a learning rate of zero point 0.1 and maximum depth of 100 and 100 estimator, maximum depth of 15 and 100 estimators. Here we have impressive R2 score approximately of 90% of training and notably 97% in R2 score around the test data. Whereas we have the MSC of 0.7 and RMSC of 2.7. Additionally, residual analysis indicate mean and median values for 0 and minus 0.09 respectively. They well behave, suggested that the XGBoost model adaptively captures underlying data patterns by minimizing the systematic errors. Thank you.